In this lesson, we're going to learn about substitution reactions. So in organic reactions, we are converting simple organic molecules into larger, more complex ones. So we have the example of Taxol here, which is an anti-cancer drug that can be synthesized from smaller molecules in a lab. The different types of organic reactions, we're going to look at substitution today. We've already talked about addition and elimination in previous lessons, and we'll be looking at oxidation and reduction, and then also condensation and hydrolysis later on. So substitution reactions are when a hydrogen atom or a functional group gets replaced by a different functional group. So we have two compounds reacting, and we have two compounds being formed, two different compounds, as we have that switching of functional groups or swapping of a hydrogen atom for a functional group. So these reactions happen to alcohols, alkyl halides or haloalkanes, and aromatics, so benzene compounds. So the general equation is that we have some type of hydrocarbon with either a hydrogen or a functional group, and then we have something else that has a functional group as part of it, and that is going to make a swap with this functional group or hydrogen. So when we have benzene, so that's our aromatic, the double bonds don't break, so that's important to note that over here, remember that this is every other bond is a double bond. And so those are not going to break. As we draw our line angle structure, we don't draw in hydrogens. But if we look at every single carbon here, every single carbon, it has 3 bonds on it. So 1 to one carbon and 2 to another. So that means that every single carbon would have a hydrogen on it, which doesn't get drawn in on a line angle drawing. So here, every single one of those carbons has a hydrogen, and so that's, the double bonds aren't going to break. We're going to have a replacement of one of those hydrogens. So let's say we have a hydrogen here, and that is going to get replaced from something over here. So if we see this as bromine attached to another bromine, so a haloalkane would be a functional group, so we're going to have a switching of those two. So one of those bromines is now going to be attached to one of the carbons on the benzene, and the hydrogen that was there is now combined with the other bromine atom. So we have bromobenzene and hydrobromic acid as the products here. For alkyl halides, here the halogen is going to be replaced with another atom or functional group. So over here we have bromomethane and a hydroxide. So here we're just showing the ion that it was paired with something else, but in a solution may be dissociating, and so that ion is in that solution. So that hydroxide is going to come and bump out the bromine to make an alcohol group here, and then that bromine is going to be an ion on its own, or it may pair with something and precipitate out. So we have bromomethane, and then as the bromine and hydroxide swap places there, now we have methanol over here. And on alcohols, we have a hydroxyl group, and that is going to get replaced with another atom or functional group. So we have a couple examples here. So we have an alcohol, the OH over here, and hydroxyl group over here. So in both these cases, we're adding hydrochloric acid, and so that chlorine is going to swap places with that hydroxide. The same thing will happen in this case as well. And then the OH, hydroxide or hydroxyl group, is going to pair with the hydrogen to make water. So we've got the chlorine and the hydroxide swapping places. So water there, and then we have our chloroethane. And then same thing here. So we have over here, we have the OH group here and the chlorine, and now we have the chlorine over here and water being produced.